I have something cool to talk about today, inverse functions. You might remember last year in pre-calc you discussed a lot about inverse functions, mainly how to get their domains and their ranges from a function. So if I have this function right here, f of x equals 2x minus 3, I want to know, does this have an inverse? Well, there's two ways we can find out. One is I can graph it. And this is our square root curve. It's going to be shifted over to 3/2, and it opens like so. Now, I know already that this is a function. I know that this is a function because it passes that old horizontal line test. That's that horizontal line test from years ago. But to have an inverse, what we're going to be doing is we're going to switch the x's and your y's. So that's what you did last year. So if this is a y, I can switch this, make this an x, and this becomes the square root of 2y minus 3. So I'm going to find the inverse. That's basically what we're going to do. I'm going to find the inverse. So to find the inverse, this becomes x squared equals 2y minus 3, or y equals x squared plus 3 over 2. Now, there is an issue with this one, where this function passes the horizontal line test. To have an inverse, well, we have a problem. It also has to pass, to be an inverse, it also has to pass the vertical line test. In other words, we have to only touch the function exactly one time on a vertical line as well as a horizontal line. This is something we call one-to-one. And in a nutshell, what one-to-one means is for every x, there's exactly one y. For every y, there's exactly one x. Think of it like a relationship. It's a good relationship. For every x, for every boy, there's exactly one girl. For every girl, there's exactly one boy. This is what we call one-to-one. Well, here's the problem with my inverse right now. See, right now, I found this right here, but if I were to graph it, this is a parabola. Like something like this. Yes, it is a function. It passes the horizontal line test, but it fails the vertical line test. So how do we make this into an inverse? Well, very simple. From pre-cal last year, we restrict the domain. So to restrict the domain, we're going to go back to our function. I know my domain here says x has to be greater than or equal to 3/2. Now, this is the range of the inverse. Remember, to get the inverse, we're just switching our x's and y's anyways. So if my domain for my function is 3/2, that tells me my range here is greater than or equal to 3/2. The range, well now, if I look at my graph, the lowest it's going to be is y is equal to 0. So it's going to be y is greater than or equal to 0. Well, this is the domain of our inverse. So if my domain, my range here is y is greater than 0, if I switch that to an x, my domain here then becomes x is greater than, such that x is greater than or equal to 0. And then this becomes an inverse, and you can put that -1 on it. So it's very easy. So we know this has an inverse because I can find it. So the inverse exists. I can find it. But what happens if we have functions that we can't graph or functions that we can't solve? So let's take a look at this function right here. Let's take a look at x cubed plus x minus 1. And I want to find out if this function has an inverse. Well, I could try solving it. Okay, let's try that. I would get x equals y cubed plus y minus 1. Oh no. Unlike right here, see here I can solve a y, but here we can't solve the y. Well, so I cannot solve the y. So I don't know if this inverse exists. See, for the first one, the square root, I know the inverse exists because I could find it and I could restrict the domain. But here, I can't find it. I can't solve for the inverse. So that's not going to work for me. So the question is, well, how can I determine if this inverse exists? Well, we go back to our 1-to-1. For every x, there's exactly one y. For every y, there's exactly one x. I'm going to use this concept to determine if this function has an inverse. And it's super simple. Let's look at two graphs. The story of two graphs. A parabola and a square root. Now, we already know that this function has an inverse. Check. This function, we already know, does not have an inverse. We already found that. Check. So the question is, well, what's really the difference between these? Think calculus. Well, let's take a look here. Oh, look. Here, the function is going down, but then it goes up. This fails the horizontal line test because as the function goes down, afterwards it goes back up. So that's why it fails the horizontal line test, because we're going back up the graph. So there's no inverse here. This fails that horizontal line test. And that is because the slope changes direction. Over here, this passes the horizontal line test. But why does it pass? Because the slope never changes direction. Now, we have a special name for this. This is called monotonic. Monotonic. And what monotonic means is that the slope never changes. The slope is monotonic. So we can use the slope to find out if an inverse does exist. So use the slope. Or in our case, what finds a slope? But the derivative. So if I take the derivative of our function, f prime of x, we're going to get, 3x squared plus 1. How do I find out where a function changes direction? Look at those critical numbers. Man, thought we never see those again, right? The critical numbers. Set the derivative, which is our 3x squared plus 1 equal to 0, and we get x squared equals negative 1/3. Well, try taking that derivative. You can't. This is a failure. You can't take the derivative because you can't take you can't take the square root of a negative number. I don't know why I kept saying derivative, not square root. Take the square root of a negative number. So, if I do my sign chart, I don't have any critical numbers here, f prime and f. So I can pick any number I want. X equals 10. And if I plug that in, I'm going to get 3 times 10 squared plus 1, which is positive, so this is a positive function. So in other words, what this is telling us that this is strictly increasing. So here's how we would write this. F prime of x is greater than 0. Therefore, we say f is strictly monotonic. In other words, it never changes. Monotonic. Therefore, f prime of x exists. Now, I may not be able to find the inverse, but I do know there is an inverse to this function, that the inverse does exist. So let's look at another problem. Let's look at something like this. X cubed minus 12x plus 1. Well, again, I can't solve this by hand, because if I did this, it would be x equals y cubed minus 12y. I can't solve this one. So if I take the derivative, we would get 3x squared minus 12. Set that equal to 0, get those critical numbers, and we would get x. This becomes x squared minus 4 equals 0. So I get x equals plus or minus 2. So when we try this one, do our sign chart, f prime and f, negative 2 and 2. Plug this into your derivative, 3x squared minus 12. Plug that into your derivative. I'll pick negative 4. That becomes 16 times 3, which is 48 minus 12. Well, that's positive, so it's increasing here. Plug in something between 0. I get negative. Already, I already know my answer. Take a look. The function goes up and it goes down. So at this point right here, we fail the horizontal line test. So therefore, we can say f prime of x does not exist. And let's talk about why. And that is because f prime of x changes direction. Or we can just say, the better way to say it, because f of x is not monotonic. There we go. That's a better way to put it. All right. I hope you enjoyed this video. I will see you all later. Bye-bye.